Hi, this is just a short video to introduce you to the new lathe at AMT. It's very similar in many ways to our former lathe, but different in some critical ones. So we're just going to work our way from one end of the lathe to the other and talk about things that are the same and different. So the first thing about this lathe is how all these surfaces lock down. So both the tool rest adjustment and the tailstock adjustment. The key thing is that when these handles are vertical, the piece is unlocked. When they are tilted to either side, the piece is locked. So it's not that you need to keep going in one direction or the other to release it. You just need to swing it to vertical and then things should slide smoothly back and forth. Also on this tailstock, we have an advancing tailstock for either live centers, dead centers, or drill chucks. And this little knob up here releases it, and then it can be advanced or retracted using the black wheel here. If you do remove the adjustable tailstock, just ensure it's aligned with the pin when it goes back in. So then we can move forward towards the bed of the tool. This tool has a maximum of 24 inches between centers, although when you put on a live center or a chuck and a faceplate and a live center on this end, suddenly you're really probably down closer to the 18-inch range, and it's 8 inches from the center of the drive end to the bed. As for the tool rest, it's the same adjustment system as the tailstock, so simply move this long handle to vertical and then adjust it as you need. And it has a little locking screw here for the tool rests, all of which are stored in this pegboard to the left of the tool as you look at it. So then moving along to the headstock, this is where things get pretty different. So this lathe is a Nova DVR XP, so it is a computer-driven lathe. So it means that it will measure the amount of force that's being applied to it by the tool as you're cutting and attempt to retain the same rotational speed while that's happening. So there are two main things about turning this on. The first is that the computer itself is turned on using this toggle switch here. So you just flick that up and you'll see this little monitor come on. It'll play a little tune, and then give you a few safety tips to make sure tells you to wear a face mask and make sure you're selected the right speed. We've set this lathe to spin at 160 RPM as its default when you turn it on. Before you set it to turn on, you need to look at this knob on the top. It's slightly worn as this is a second-hand lathe, but faintly you can see on this side it says unlock and this side it says lock. The side that is towards the red panel is the side that is active. So you want to make sure it's unlocked so that the unlock label is on the same side as the red panel. To change it, you simply lift it and rotate it. And you'll notice that now the headstock cannot be spun by hand. But if I lift it and turn it to unlock, I can easily spin it by hand. So you want to make sure that the headstock is released and that the computer is on. It'll say ready to run across the bottom here, and then you simply press the on button and the lathe will begin to turn. You can then set your RPM using the up and down arrows to speed it up or slow it down. I think its maximum speed is around 3,200 RPM. I would recommend, if you're starting to bring something into round, starting around 500 RPM. Entirely up to you. You'll have to figure it out piece by piece. I like to start around 500 as my approximate starting point. When you're ready to stop, you just press off. That does not actually turn off the computer, it just turns off power to the motor. You can switch which direction of turn just using the forward and reverse here. If you want to get into the programs and options here, you can set it to do ramp up and ramp down or oscillate speed for sanding purposes. There's an orange folder, this guy right here, which has the full user manual in it that we keep in the tool storage cabinet. So if you want to get into that, feel free. We're not going to cover it in this particular video. The last major thing about this lathe is that, I'm going to turn off the computer just because we don't need to look at that anymore, but as you turn it off, you'll notice it'll say low voltage here. That is normal. It's just that it has a fairly large capacitor in it, so when you turn it off, it starts to ramp down. The last thing is that this lathe, the headstock can be rotated so that you can turn bowls and larger pieces outboard, anything larger than the 8-inch throw you have here. In order to do that, it's quite simple. You use this bar here to loosen this pin. You don't need to unscrew it all the way, just make it loose enough that you can kind of feel the pressure coming off. If it's unscrewed all the way, it's kind of a pain to get it all back in. So now I can turn it by hand, that's plenty loose. And then I swing this lever on the bottom to this side, and then the headstock can be rotated to allow me to turn outboard. I swing the lever back over and adjust it to make sure it's seated in its detents, and then tighten this back up. It doesn't need to be extremely tight, it just needs to be snug. The detent is really what holds it. This just reduces vibration. So normally I'll do about, maybe a turn and a half at most, and then I tend to just leave the knockout bar there. We are going to leave the lathe in its long orientation as its default, so if you do turn outboard, please just turn it back to be in line with the bed. And once that's done, you can simply throw your lever over again, spin it back, lever back, adjust it until it's sitting in its detent, nice and snug, and then we can just tighten it up again. The bar that we use in this locking pin here is also the knockout bar. So people may remember from our old lathe that when you'd use something like a spur center, say, we had problems with them becoming wedged in there, and people made all sorts of weird jigs to pull them out, or there was a nut that you should have put on in advance to make sure it could be extracted. This lathe doesn't work that way. It doesn't, you don't put an extractor nut on. You use this bar to knock the piece out. So they can be in there quite snugly, but you can simply insert, once the lathe is off, you can insert this bar through and just tap it with a mallet and it will knock this piece out. That's how we remove tools that are using the Morris taper in the center. Obviously for chucks and stuff, they thread on and should be unthreaded. Speaking of chucks, all the ancillary parts, and we now have a huge amount because the person from whom we got this lathe was extremely generous, but there's a whole series of chucks down here with bowl holding jaws, multiple sets of those, easy chuck systems, as well as a whole new set of the easy wood tools in addition to the set we already have, including a tool we did not have before, an interior gouge, which is really nice to have. They all live down here. One thing that we now have that we didn't have before was a series of polishing discs, or buffing wheels, I should say. And you'll notice when we take these out that they've been labeled, so like wax 3, 1. So, I mean, this is how the previous owner used them. It's pretty much just the order in which you use them. So if you're going to wax something up with these, start with 1, then move to 2, then move to 3. It just extends the lifespan and leaves them longer. That's everything that's really changed about the Nova DVR. Thank you, everybody, for paying attention to it. Those who've been certified, your certifications remain valid so long as you've watched this video. And if you're unsure, reach out on Slack and we'll help you get up to speed with the new lathe. Thanks. Bye.